Now, the first unit of discrete mathematics is logic and mathematical induction. For computer science students, this unit is very important. Now, these are the points that we study in first unit, that is logic and mathematical induction. Now, first is propositional logic and propositional equivalence. Now, first see what is the meaning of proposition or statement. A proposition or statement is a declarative sentence, that is, it is a sentence that declares a fact, that is either true or false, but not both at the same time. So statement or proposition must be a declarative sentence. That means it cannot be exclamatory sentence or interrogative sentence like that. At the same time, it must be either true or false, but not both at the same time. Now, we denote propositions generally by small letters P, Q, R, etc. Now, as by definition, proposition is either true or false, but not both at a time. The truth or falsity of a proposition is called its truth value. When a proposition is true, its truth value is true and it is denoted by capital T. When a proposition is false, its truth value is false and it is denoted by capital F. Henceforth, we are using for true and false capital T and capital F respectively. Now see some examples to clear the definition of proposition or statement. Now first is 7 is a prime number. So this is one declarative sentence and 7 is a prime number, that is correct. That means it is true. So truth value of this statement or proposition is true. Mumbai is in Maharashtra. Again, this is a declarative sentence and yes, Mumbai is in Maharashtra. It means it is true. So truth value is true. Now 2 plus 5 is equal to 10. Again, it is a declarative sentence. So it is statement because even though 2 plus 5 is not equal to 10, we can say that it is wrong. That means its truth value is false. So it is declarative sentence with truth value false. So it is a statement. Not necessary that 2 plus 5 we have to write as 7 because this is just a declarative sentence. So if we are writing 2 plus 5 equal to 7, it is again a statement with truth value true. But as we are not writing 2 plus 5 equal to 7, its truth value is false. Chennai is the capital of India. Again, it is a declarative sentence. But is Chennai capital of India? No. New Delhi is the capital of India. So the truth value of this statement is false. So these are some examples of statement or proposition. Now see some sentences which are not propositions. Do you know Kokri? Now, this is a question. This is not a declarative sentence. That means it is an interrogative sentence and so it is not a proposition. Close the window. It is an imperative sentence. That is, it is a command and not a declarative sentence. So, this is not a proposition. X plus 1 equal to 3. Now, this is declarative sentence in which the value of x is not specified. So if value of x is specified, that means there is no unknown or variable, then we can say that it is a statement like 2 plus 5 equal to 10. But here if x is equal to 2, then 2 plus 1 equal to 3 is true. But for other values of x, it is false. So we can't say whether it is true or false definitely. And hence it is not a statement or proposition. In the same way, x plus y is equal to z. About this, we cannot say whether it is true or false because we don't know the values of x, y and z. So again, it is not a statement or proposition. Now next is propositional logic. Now propositional logic is a mathematical system for reasoning about propositions and how they relate to one another. So in propositional logic, we study about the reasoning about propositions and how they are related to each other. Now logical connectives. Now logical connectives are the words or phrases which combine two or more propositions. Now we use generally the words and, but, not, if, then, either, or are some of the connectives which are commonly used to join two or more statements or propositions. So all these are logical connectives. Now, depending upon whether logical connective is used or not, there are two types of statements. Now, first is simple statement. A statement which does not contain any logical connective is called a simple statement. For example, there are 7 days in a week. So, this is a statement in which we are not using any logical connective like and, or, but, etc. So, this is simple statement. Second is root 2 is a rational number. Yes, root 2 is not actually a rational number. Root 2 is an irrational number. That is true. But this is a declarative sentence with false truth value. So it is again a statement. And here we are not using any logical connective. So it is a simple statement. Now another type of statement is compound statement. A statement which contains logical connective is called a compound statement. For example, 2 is a prime number and 2 is an even number. So here two statements, 2 is a prime number, 2 is an even number. These are joined by using logical connective and. So this is a compound statement. Now second, I will watch the cricket match on TV or go to the Wankhede stadium. Now there are two separate statements. I will watch the cricket match on TV. Another, I will go to the Wankhede Stadium. Now these are combined by using logical connective or. So this is again an example of compound statement. Now the new sentence obtained by using a logical connective is a proposition only when it has truth value T or false F but not both. So whenever we are using any logical connective, the new sentence that we are getting is proposition only when it has definite truth value, either true or false, but not both. The truth value of the new sentence depends on the truth values of the sentences from which it is formed and also the connectives used. So the truth value of new statement depends on the logical connectives used and truth value of each statement separately. Now, truth table. The truth values of a sentence formed by using logical connectives is given in the form of a table that is called its truth table. Now, first is negation, that is type of compound propositions. Let P be a proposition. The negation of P is denoted by either this symbol or this symbol. It is the statement, it is not the case that P. The proposition negation P, this is read as not P. So, whenever P is certain statement or proposition, not P, or it is not the case that P is nothing but negation of P. Now, what is the truth table for negation? See, as P is a proposition, it has truth value either true or false, means T or A. So, whenever a statement P is true, definitely its negation is false. And whenever P is false, negation of P has truth value true. So this is the truth table for negation of P. True, false, false, true. Now see some examples. Suppose P is the statement Paris is the capital of England. Now what is negation of P? It is not the case that Paris is the capital of England. Or we can write directly as Paris is not the capital of England. Now, if you consider negation of negation P, then it is not means not will get cancelled. So, Paris is the capital of England. So, actually, negation of negation P is same as our original statement P. So, in terms of logic, P and negation of negation P, these two statements are logically equivalent. Now, see second example. Q is the statement 2 plus 1 equal to 3. So what is negation of Q? 2 plus 1 not equal to 3. and negation of negation Q is 2 plus 1 equal to 3. So negation of negation P is always P. Now, second is conjunction. Let P and Q be propositions. The conjunction of P and Q is denoted by this symbol. It is the proposition P and Q. The conjunction P and Q is true when both P and Q are true and is false otherwise. Now here, instead of single statement, we are considering two statements or two propositions PQ. Now, as P and Q both are propositions, each has truth value either true or false. So depending upon their truth values, there are four cases. P is true and Q is true, means both are true. Then P is true, Q is false. P is false, Q is true, and both are false. So in every case, we write what is the truth value of statement P and Q. Now P and Q is true only when both are true and is false otherwise. That means only in the first case when both P and Q are true, P and Q has truth value true. And in remaining cases, P and Q is always false. Now, P is the statement 16 is an even number. Q 16 is a perfect square. So how to write P and Q means P conjunction Q in English? It is 16 is an even number and 16 is a perfect square, or it is a perfect square. So here PQ we are joining by using the logical connective and. So remember, this is the symbol for P and Q. Now another example, P, the sun is shining. Q, it is raining. So P and Q is the statement, the sun is shining and it is raining. So here we have joined them by using logical connective and. Now, in logic, the word but is used sometimes instead of and in conjunction because it is more appropriate word. So instead of and sometimes but is also used. See the statement, the sun is shining but it is raining. So instead of writing the sun is shining and it is raining, the sun is shining but it is raining is more appropriate. So and but both are nothing but conjunction. Now third is disjunction. Let P and Q be propositions. The disjunction of P and Q denoted by this symbol is the proposition P or Q. The disjunction P or Q is false when both P and Q are false and is true otherwise. So see the truth table for disjunction. Again, as PQ are two propositions, there are four possibilities about their truth values. Now in case of disjunction, P or Q is false only when both are false. It means when both are true or at least one is true, we get P or Q as true value. And P or Q is false only when both are false. So it is enough to remember that particular case. Now see how to join PQ by using logical connective or. Now P is I will watch the cricket match on TV. Q I will go to the Wankhede Stadium. So P disjunction Q is nothing but I will watch the cricket match on TV or I will go to the Wankhede Stadium. So here we have combined PQ by word or. Now P, there is an error in the program. Q, the data is wrong. So P disjunction Q is there is an error in the program or the data is wrong. So again, here we have combined PQ by using the logical connective or. Now, fourth is implication or conditional statement, that is if then. Let P and Q be propositions. The conditional statement or implication denoted by P arrow Q is the proposition if P then Q. The conditional statement P implication Q is false when P is true and Q is false and true otherwise. So remember, only special case whenever P is true and Q is false, then only P implication Q is false. Otherwise, it is true. Now see this table. Here again there are 4 rows because there are 2 variables P, Q. Now whenever P is true and Q is false, then in that case only P implication Q is false. In other cases it is true. Now see the logical connective if then how to use if P and Q are given. Now P is the statement it rains. Q, I wear a raincoat. Now what is P implication Q? So it is nothing but if P then Q. So in English we write this statement as if it rains then I wear a raincoat. Now another example is P, you are good in logic. Q, you are good in computer science. So again, what is the statement P implication Q? It is if P then Q. So if you are good in logic, then you are good in computer science. Now see some remarks. Now what we say for P and Q in the implication, P implies Q. Now in the conditional statement P implication Q, P is called as the hypothesis or antecedent or premise and Q is called as the conclusion or consequence. So in P implication Q, P is antecedent or hypothesis or premise and Q is nothing but result or conclusion or consequence. Now there are some other ways to express P implication Q instead of writing if P then Q. So instead of that just we can write if P comma Q without word then. So again it stands for P implication Q or P is sufficient for Q. It means P is enough for Q. It means if P is happening, P is there, then definitely we'll get Q as a result, as a consequence. So P is sufficient for Q. Again it stands for P implication Q. Then instead of writing if P then Q, we can write it as Q if P. Then Q whenever P. So whenever is same as if. Then P implication Q can be written as Q is necessary for P. See there is difference. Q is necessary for P means if P is there then definitely Q will happen. Then Q when P. Q follows from P. A necessary condition for P is Q. So these are many ways to represent implication. Now, the last is by implication or by conditional statement. Now, the word by stands for two. So, by implication means it is two-way implication. Now, P and Q, these are two propositions. The biconditional statement denoted in this way, both way arrows are there, is the proposition P if and only if Q. The biconditional statement P if and only if Q is true when P and Q have the same truth values and is false otherwise. It means when both P and Q are true, then P double implication Q is true. Or if P and Q both have false value, then also P double implication Q is true. So this is the truth table for biconditional statement. See here. Here P and Q have same truth value T. So P double implication Q is T. And in last row P and Q both have F value same value. So P double implication Q is true. And in remaining cases 1 true 1 false, the value is false. Now, these are some examples. P is I am rich. Q, I own a Ferrari car. Now, how to write the statement P double implication Q? It is nothing but P if and only if Q. Now, P is I am rich. So, I am rich if and only if I own a Ferrari car. Now, another example. P, two lines are parallel. Q, two lines have the same slope. So how to write P double implication Q? So it is P if and only if Q. That is two lines are parallel if and only if two lines have the same slope. Now What is the another way of writing P double implication Q? Actually, as it is biconditional statement, this part implies P implies Q, and this arrow from right to left it implies Q implies P. So there are both ways implication. One is P implication Q and another is Q implication P. Now P implication Q means P is sufficient for Q, and Q implication P means P is necessary for Q. So this statement can be written as P is necessary and sufficient for Q. So instead of using the word if and only if, it can be written as P is necessary and sufficient for Q. This is very important part, because if the word if and only if is missing, then students get confused. What is this logical connective used? So you have to remember this part, that necessary and sufficient is same as double implication or by implication. Now another way is if P then Q and conversely, because in logic if P implies Q, its converse is Q implies P. So here it is P implies Q, at the same time Q implies P, means converse is also there. Then in short you can write this as P I double F Q, that is P if and only if Q. So these are different ways of representing by implication or by conditional statement. Now see this note, if there are n propositional variables in the proposition, then the number of rows in a truth table is equal to 2 to the power n. So if there are two variables in the proposition, then number of rows in the truth table is 2 square, that is 4, like that. Now we have seen 5 truth tables. One is negation, then disjunction, conjunction, implication and by implication. But you must remember all these truth tables, then only you can solve problems based on the truth tables. And there are many problems that you have to solve in logic by using the truth tables. So if you don't know what are the standard truth tables, then you cannot solve that problems. Now these are some simple questions. Which of these sentences are propositions? What are truth values of those that are propositions? So first you have to decide whether the given sentence is a proposition or not. If not, then answer is no. But if yes, then you have to find its truth value also. Now the first is the earth is a planet. Now this is a declarative sentence and it is true. So we can say that this is a proposition with truth value true. Now second is may God bless you. Now this is not a declarative sentence and hence we are not writing any truth value. Now third is one is a prime number. Now this is a declarative sentence. Actually one is not a prime number, but it is a declarative sentence whose truth value is false. So this is a statement and its truth value is false. Now next is beware of dogs. Again this is not a statement because this is not a declarative sentence. Then next, the sum of the angles of a quadrilateral is 180 degree. Now again this is a declarative sentence and actually sum of angles of quadrilateral is not 180 degree but it is 360 degree. So even though it is declarative sentence, it is a statement and truth value is false. Now next is x plus 3 equal to 12, x in z. Now x is an integer, x can take any value. So if x is 9, we get 9 plus 3 equal to 12, which is true. But for the remaining integers, x plus 3 equal to 12 is false. So we can't say whether it is true or false. So this is not a. Now Satish has more than 10 GB free disk space on his handset. Now, how to write its negation? So, more than 10 GB means greater than 10 GB. Now, not more than 10 GB stands for less than or equal to 10 GB. So, how to write its negation? Satish has less than or equal to 10 GB disk space on his handset. Now, the next question is, let P and Q be the propositions. P is given as Aishwarya is tall and Q is given as Aishwarya is beautiful. Now, write these propositions using P and Q and logical connectives. Now, first is Aishwarya is tall and beautiful. So, we have to write it in symbolic form. Now, this is actually Aishwarya is tall and Aishwarya is beautiful. So, this is P conjunction Q. Now, second is Aishwarya is tall but not beautiful. But is same as and. So, this is Aishwarya is tall and Aishwarya is not beautiful. So Aishwarya is tall means P and Aishwarya is not beautiful means negation of Q. So this is P and negation Q. Now third one, Aishwarya is not tall but beautiful. So but is same as and. So this is Aishwarya is not tall and Aishwarya is beautiful. So not tall is negation P and Q. Now, Aishwarya is neither tall nor beautiful. It means Aishwarya is not tall and Aishwarya is not beautiful. So both negations are there, joined by and. So it is negation P and negation Q. Now next is, if Aishwarya is not tall, then she is not beautiful. As if then is used here, this is implication. Now Aishwarya is not tall is negation P. She is not beautiful is negation Q. So this is negation P, implication, negation Q. Now Aishwarya is tall if and only if she is beautiful. Aishwarya is tall is P, Aishwarya is beautiful is Q, and we are combining them by using if and only if. So this is P double implication Q. So these are the answers. Now P and Q, these are propositions. P is swimming at the New Jersey shore is allowed, and Q is sharks have been spotted near the shore. Now we have to express the given compound propositions as an English sentence. Now first is P conjunction Q. So conjunction is nothing but join PQ by using the word and. Now what is P conjunction Q? Just join PQ by using the logical connective and. Now P is swimming at the New Jersey shore is allowed and sharks have been spotted near the shore. Now second is negation P disjunction Q. So we have to consider not P, Q and we have to join them by using the logical connective or as disjunction is there. So negation of P is swimming at the New Jersey shore is not allowed or Q means sharks have been spotted near the shore. Now, third one is P implication, negation Q. So, implication means if antecedent, then consequence. That means if P, then negation of Q. So, after P, we write P as it is, and after then we write negation of Q. So, the statement will be if swimming at the New Jersey shore is allowed, then sharks have not been spotted near the shore. Now, next is negation Q implies P. Now, this is similar to third one. If not Q, then P. So, after if we have to write negation of Q and after then we write statement P as it is. So, it is if sharks have not been spotted near the shore, then swimming at the New Jersey shore is allowed. Now, fifth one is negation P, implication, negation Q. So, this is if negation P, then negation Q. So, for negation P, it is not P implies not Q. If swimming at the New Jersey shore is not allowed, then sharks have not been spotted near the shore. And last is P by implication, negation Q. So here we are joining P and negation Q by using the logical connective if and only if. So after P we use the word if and only if, and then we write not Q statement. So this is swimming at the New Jersey shore is allowed if and only if sharks have not been spotted near the shore. In this way, if we are given the proposition in symbolic form using logical connective, then we can convert them as an English sentence. Now, how many rows appear in a truth table for each of the given compound proposition? Now, the first is P implies negation P. Now, in this compound proposition, there is only one variable, that is P. Now already we have seen that if there are n number of variables, then the truth table contains 2 to the power n number of rows. So as there is only one variable, number of rows is equal to 2 raised to 1, which is 2. Now second statement is P disjunction Q implies P and Q. Now it contains two variables, namely P and Q. So number of rows in this proposition, number of rows in the truth table of this proposition is equal to 2 raised to 2, which is equal to 4. Now third is P and negation Q and R or negation S. Now count the number of variables P, Q, R, S. There are 4 variables in this compound proposition. So in the truth table, number of rows will be 2 raised to 4, which is 16. So in this way, if there are n number of variables in the proposition, then the truth table contains 2 raised to n number of rows. Now, in next problem, we have to construct a truth table. Now, the statement is P or Q implies P and Q. Now, the first thing is that how many columns will be there and how many rows will be there. Now, as there are only two variables, there will be 2 square, that is 4 rows in the truth table. Now considering the requirement in the statement, we prepare the columns. Now as there are two variables, first column is of P, second column is of Q. After that we need to calculate truth values for P or Q. So we form the third column as P or Q. Now to find the truth value column for this statement, we need to find the truth values of P and Q. So next column will be P and Q. Now after getting the truth values for these two columns separately, we can write the column for P or Q implication P and Q. So in this way, there will be columns P, Q, P or Q, P and Q, and finally P or Q implies P and Q, and there will be 4 rows. Now see how to prepare the table. But to prepare the table, you must know what are the truth tables for disjunction, conjunction and implication. Now see how to write the 4 rows. Now you can keep one pattern of writing the rows. Now both are true, then P true, Q false, then P false, Q true, and then both are false. Now remember, disjunction is false when both are false. So in the last row, P, Q both are false. So for P or Q, this value is false. It means in remaining values, we can write directly as true. Now, what is the truth table for P and Q, P conjunction Q? Now, P conjunction Q is true when both are true. Now, in the first row, P, Q both are true. So, here in this row, we write P and Q as true and remaining values as false. Now, the next is P or Q implication P and Q. Now, implication is false when antecedent is true and consequence is false. It means whenever P or Q has true value and P and Q has false value, then only we get false value. So just find the values where P or Q is true and P and Q is false. Now here in first 3 rows P or Q is true. But at the same time, P and Q must be false. So these are the two middle rules. Now here it is true and it is false. So true, false is false. Again here P or Q is false. P or Q is true. P and Q is false. So it is false. And the remaining true we write directly as true value. So this is the truth table. Now in this question we have to prepare just the truth table. So what it stands for when P and Q both are true, in that case this statement is true. When one is true, another is false, then in that case this statement has false value. And when both are false, then again the statement has true value. Now, second is P and negation Q, implication P or Q. Now, as there are two variables PQ, again the truth table contains four rows. Now how to prepare the columns? First column is of variable P, second is of Q. Now to find the column for P and negation Q, we need to find first truth values of negation Q. So next column is of negation Q. Then it is possible to write P and negation Q. Now as PQ are there, you can write P or Q. Now once you write columns for these two brackets separately, the final column will be of implication. Now this is the truth table. See P, Q, again same four rows. Now what is negation of Q? Whenever Q is true, negation Q is false. And Q is false, negation Q is true. Then P and negation Q. Take the columns properly. We are not writing P and Q, but it is P and negation Q. So we are considering first and third column. So in case of and, it is true when both have true value. So in case of P negation Q, in second row both are true. So we get this value true and remaining values false. Now next column is P or Q. Now disjunction is false when both are false. So only in the last row we get false value and remaining values are true. Now next is implication. So in case of implication, when this antecedent is true and consequence is false, then only we get the false value. So only think of P and negation Q true and P or Q is false. Now here in P and negation Q, in second row only this is true value. At that time here no false value. So there is no case of true false. So there is no false value. It means all values are true here. So this is the truth table. Now this is third statement. It is P implication, negation, Q and R. Now, there are three variables, namely P, Q and R. So, number of rows equal to 2 raised to 3, that is 8. So, there will be 8 rows. So, prepare the table carefully. Now, how to take columns? Now, first three columns will be for three variables, namely P, Q, R. Now, to form the column of truth values for this, first we find for Q and R. So, next column is of Q and R. Then we can take its negation. And after writing this column, we can write implication. Now, how to write that 8 rows? See, here it is easy to remember. Now for P, we write first 4 rows as true and next 4 rows as false. Now for first 4 rows for Q and R, how to write? Now it is similar to two variable table, that is TT, TF, FT and FF. And again repeat that rows for last 4 rows, that is TT, TF, FT, FF. See once again, while writing that 8 rows, in the column of P, we are writing first 4 rows as P and last 4 rows as F. Then for Q and R, the first 4 rows will be similar to two variable, that is TT, TF, FT, FF. And again write same 4 rows in the last 4 rows. Now considering that table of and, negation, implication, this is the truth table.